Yes. Wonderful. So I should send the questions in the chat again. Thank you very much. So that we all have access to it. And also I'll be only keeping track of the of this chat and not the M25 Math AA. So just keep that in mind. If you have any questions, feel free to let me know. Feel free to stop me. And I'll be more than happy to answer. Okay. 1. Indices. So let's start with question 1, shall we? Give it a go. And we'll go over it in 30 seconds. Terrible numbers. Fuck. Okay. Yes, I will let you know if a question requires the use of a calculator. Otherwise, the default is that you are expected to do all of it without calc. When do you say your answer? Anytime. Might want to put a spoiler, but yeah, that's fine. Okay. 1A is, of course, a warm-up. So, x cubed is as is. 3x squared, that's going to be 3 squared times x squared over 6x to the 5. 3 squared, that's 9. X cubed times x to the 4 divided by 6x to the 5. Simplifying the constants. Simplifying the powers. Multiplying two exponents with the same base, we add multiplying two powers with the same base, we add the exponents. Dividing two exponents with the same base, and two powers with the same base, we subtract the exponents. And that gives you 3 over 2 x squared. B, by the way, this if you're at the end of the course and you're struggling with this, yeah, it's gonna be a bit scary. Okay, second one. This time around, we have a negative and a fractional exponent, or index, if you're in the UK. Negative means that we gotta flip the fraction to the power of 2 over 3. Using the same rule as above, this gives us y cubed to the 2/3 divided by 27x to the 6 to the 2/3. Numerator, y squared. Okay, should I write out all the steps? that might be useful. Okay, 3 times 2 over 3. Downstairs, 27 to the 2 over 3 times x to the 6 times 2 over 3. Numerator, we have y squared. 27 to the 2 over 3. How do we evaluate this? That's 27 to the 1 over 3 squared times x to the 6 times 2 over 3, 4. 27 to the 1 over 3, or the cube root of 27, 3 squared, you get 9. So final answer, y squared over 9 times x to the 4. Are we good so far? Okay, I will take it as a yes. Moving on to question 2 then. The 3 factors here are very similar for a reason. So the product is equal to 0 if this guy is equal to 0, or this guy is equal to 0, or this guy is equal to 0. Factorizing this. Okay. How do you factorize any of this? Just a quick question. The x thingy? What do you mean? Oh, I see what you mean. Okay, yeah. Yeah, so basically, all 3 of them are hidden quadratics. So you can choose to use a dummy variable in this case, just to convince yourself that these are all quadratics in disguise. However, you don't have to do that. But if you let t equals x root x in the first case, you should get t minus 8 times t plus 1 equals 0 after factorization. Literally same thing over here, but just to not confuse people, I'm going to use a different letter. This implies that t is equal to 8, or t is equal to negative 1, v is equal to 8, or v is equal to negative 1, w is equal to 8, or w is equal to negative 1. X to 3. Okay, if t is equal to 8, then we get x root x is equal to 8. If t is equal to negative 1, you get x root x is equal to negative 1. Likewise over here. Likewise over here. And this is where I would like to bring your attention to. X root x cannot be negative. Why? this guy has to be positive, right? Because it's under the square root. That means that x root x has to be positive because x is positive and root x is positive. So this is not an option. However, if we have an odd power like this, it can perfectly be negative. That's totally fine. By the way, we are solving in a real set. Just for some sucklers out there who keep arguing that, well, that can actually happen if we bring in complex numbers. No, we don't care about that right now. Back to this. X to the 4 is equal to negative 1. Is it possible? No. Because we have an even power, it cannot be negative. So essentially, we are now down to 4 equations to solve. X root x is equal to 8, or x cubed is equal to 8, or x cubed is equal to negative 1, or x to the 4 is equal to 8. X root x is equal to 8, x to the 3 over 2 is equal to 8, x is equal to 8 to the 2 over 3, x is equal to 4. Second guy, very straightforward. Third guy, also straightforward. Last one, how many solutions do we have? Two, even power. On your exam, wait, can we take a negative root here? No, we cannot. Why? Because in the original equation, we already have the root x. This forces all of your x to be positive. So a negative root here is not an option. Secondly, on your exam, you will get full marks for this, even though it looks ugly. Personally, I would rather write it as 2 to the 3 over 4. But that's just a matter of aesthetics. You do not have to do this. But I do because it looks nicer. You don't have to. It's not a must. Question 3. Exactly. The fourth root just looks ugly. I don't want to. I mean, it just looks bad. And math is elegant. So moving on to question 3. Would you guys like to have some time to work through the question first? Okay. There are several ways to, okay, can I start working through the question? Okay. How do you expand the numerator? You have two options. You can either use the Pascal triangle, or because you've seen this way too many times, you can just write it down. And this is convenient because I asked you to give your final answer in descending powers. X cubed divided by x squared, 3x squared, whatever, divided by x squared, gone. Third term, 3. Last one, minus 1 over root x. To give it in the required format, 1 times x to the 1 minus 3 times x to the 1 over 2 plus 3 minus x to the negative 1 over 2. A, B, C, D, P, Q, R. Simple. Question 4. So I will give you guys a minute to have some fun with it, mess around, and see how far you guys get to. This question could be fun to give at the start of the exam. It's not too easy, but it should also be doable. Okay, what do we do? So we look at this question. We see two different bases. We have different bases. We cannot multiply. We must convert them to the same base first. One over 2 root 2. That is essentially 1 over 2 to the 1 times 2 to the 1 over 2. Left hand side, x plus 2, we get 2 to the x plus 2y right-hand side, 2 to the negative 3 over 2. Therefore, this must be true, and we can bring it home. Oh, good. Thank you. Question 5. Last one. So this is a quick recap of radicals, or surds, if you're using the UK term. At SL, it is not too crucial, but you still expected to be able to manipulate them. At HL, this is crucial. Part A. Simplify this. Actually, scratch that. I would need to change this to 1 over 3. Root 27, that's root of 3 squared times 3. 4 divided by root 2. 2 ways to go about it. Personally, I would rather write 4 as 2 times 2 and 2 as root 2 times root 2 so that you can cancel out. Root 18, same principle, 3 squared times 2. Last one, root of 1 over 3, that's minus 1 over root of 3. Root of 3 squared times 3, that's going to be 3 root of 3 minus 2 root of 2 plus 3 root of 2 minus. We do not want roots in a denominator, so we are going to rationalize it. Multiplying both the top and the bottom with root 3, it should give you root 3 over 3. 3 root 3 minus root 3 over 3, that's 8 over 3 root 3. Negative root 2 plus 3 root 2, that's going to be root 2. Final answer. Part B. There are a lot of ways to go about this part. Some are faster than another. One option, the one thing you can do is you can combine the fractions. This is probably the slowest way. I would not do that. I would treat the two terms separately. First one, this is a very clear cue that we will need to rationalize. So we got to multiply by the conjugate. Second term, what happens if we take root 3 out as a factor? We are left with root 5 plus 1. Those are root 5 plus root 3. Convenient, because that is also exactly what we have downstairs. Cancellation time. No, that's the wrong cancellation. Root 5 minus root 3 times root 5 plus root 3, that's going to be 5 minus 3. For the top, we have that. Second term, plus root 3. 4 divided by 5 minus 3, 2. So your final answer is 2 root 5 plus 3 root 3. C. Now we'd like to solve the equation. This root is equal to x plus 2. Whenever dealing with radicals, always check for extraneous solution. We want to get rid of a square root. So what are we going to do? We're going to square both sides of the equation. Okay. I'm going to shove everything to the right hand side. That's gone. You have 2x minus 4 is equal to 0, or x is indeed equal to 2. Does it actually work? Check. Left hand side, we get the square root of 2 squared plus 2 times 2 plus 8, or square root of 16, or 4. Right hand side, we have x plus 2, or 4. They're equal, we're good to go. Therefore, x equal 2 is a solution. Also, another thing that you might have noticed. What is this? That is just a very formal period used at the end of a problem. This is more a presentation. Do you have to do this for IB? Never. Do you have to do this for uni? Never. But it's just a nice way to signal to your readers. This is the end of my solution. Please move on. Any questions so far? If not, then we're going to get to the fun part. Logarithms. I might want to have, should we ping people? Because I know a lot of people probably dropped out at indices because they really think that it's all well and good. And now this is where the fun starts. So M25. Let the fun begin. Question 1. Log base 3 of 5 plus log base 3 of 15 minus 1 over 4 log base root 2 of 4 divided by 4 log base 9 of 2 plus log base 3 of 5 over 4. What a way to start logarithms. Here's the thing. This question basically covers everything you need to know for logarithms or for properties of logarithms. First thing first, apart from panicking, what do you do? We see this question. Anywhere to start, any term that you can evaluate. Also, do not be surprised if you see this kind of question on paper 1. Yes, we call it log base 9 of 2. Okay. Wow, okay. So we have a misconception right off the bat. Wonderful. So let's start off with the constituents, with the parts. Log base 3 of 5 plus log base 3 of 15. We are adding 2 logarithms with the same base. So we are allowed to do that. That would give us log base 3 of 5 times 15, or log base 3 of 75. And this is why I love logs so much. A lot of people mess it up. So log base 3 of 5 to the n is equal to n log base 3 of 5. But if you have log base 3 of 3 times 5, that's not the same thing as as 5 log base 3 of 3 or whatever. So keep that in mind. First part done. Second part, 1 over 4 log root 2 of 4. Can you guys evaluate this immediately? As in, like, can you guys evaluate this expression as a number? Yeah. Okay. I'm not sure if that helps. Oh yeah, if it helps you, go for it. 4, that's 2 squared. 2, that's root 2 squared. So that's basically root 2 to the 4. Okay, I should break it down to 2 steps. 2 squared. So that's log root 2 of root 2 to the 4. This guy's equal to 1. So we're good to go. I'm doing it in a ton of details. On the exam, I think everyone would be happy if you jump from here straight to there. Okay, should I write 4 over 4 then? That probably helps. So, second term, done. Third term, 4 log base 9 of 2 plus log base 3 of 5 over 4. This is where a lot of crimes are committed. Right off the bat, we have different coefficients. So we know that we are not allowed to add them immediately. Secondly, we have different bases. So obviously you also cannot add them immediately. So we got to change the base. That's the only option. And we should change to base 3 so that we can eventually add. So log base 9 of 2, that's log base 3 of 2 divided by log base 3 of 9. Log base A of B, that's equal to log base C of B over log base C of A. Plus log base 3 of 5 over 4. Log base 3 of 9, 2. So, okay, I should redo it step by step. 4 times log base 3 of 2 divided by 2 plus log base 3 of 5 over 4. Am I going too slow? Two log base 3 of 2 plus log base 3 of 5 over 4. Same base, different coefficients. You cannot add them. So we got to make them. So we got to bring the 2 up there to make the coefficient 1. I don't want to do this, but I have to. Color coding. That 2 in front now becomes the exponent. Log base 3 of 5 over 4. Now they have the same coefficients. Now we can add them. That's wrong. So what have we done so far? We tackled this part, we tackled that part, we tackled this part. Log base 3 of 5 minus log base 3 of 4. Yes, but yeah, we'll end up with the same answer. There's a myriad of ways you can go about this. So let's call it I. Log base 3, the first part, we already did it. That's log base 3 of 75. Second part, we know that's 1. Denominator, we know that's log base 3 of 5. What do we do here? Not the same base, so we gotta make them the same base. So we gotta express 1 as a logarithm with base 3. In other words, log base 3 of 3 divided by log base 3 of 5. So that's gonna be log base 3. When you subtract two logarithms with the same base, you divide the arguments. This is change of base, but in reverse. Yeah, this question took me about 10 minutes to write. Because I really want one single example to encapsulate everything you've seen in logarithms. So it can be a bit overwhelming. but it basically shows you all the techniques. 6, probably. Yeah, don't ask me about mark allocation because I really don't know. You probably get 1 mark for this. I say I don't know because I don't really care about it. Like you've seen my unit test. I don't care about how many marks each part is going to worth. I just care about can you do it. So 1 mark for the addition. Probably another mark for change of base. So maybe this is worth another mark, maybe 2. This is gonna worth a mark, that's for sure, change of base. Bare minimum, you're gonna get 1 more mark for this, 1 more mark for that, and 1 more mark for the final answer. So bare minimum, 6. Question 2. Another classic, but this one is easier. Yes, we only cover SL today because we already have enough stuff for SL. Okay, so this question is a lot more straightforward, I hope. Still gonna be the second half of session A though, for SL. A is equal to log base 2 of 3, B is equal to log base 2 of 15. What is this? If you're not sure where to start, I would start with the end in mind. 10 is 5 times 2. So we know that we gotta get something like this. Also, notice that A and B are given as logarithms with base 2. That means that we will have to change the base. And now it is a lot easier because you can see what to do next. We need log base 2 of 5. We have log base 2 of 3, and we have log base 2 of 15. So we can just decompose the 15 into 3 and 5. B, A, what we need. So the final answer is 1 plus 1 over B minus A. You can simplify your answer. This will get you full marks. But if you're like me, I would rather put it like this. Questions, complaints, comments? We'll be going through this entire paper. We shall see. That was the plan. I don't know if we can do it because we're almost an hour in and we are still warming up. So, question 3. Find the domain of each function. What is the domain of this guy? Quick. This one should be giveaway. Yeah. Come on, guys. This one should be a giveaway. Nope. Yes. All real numbers. So X is an element of all real numbers. Yes. B. No. We'll talk about the range later. That's actually going to be the next question. What is the domain of a logarithmic function? Again, the domain. We're not talking about range here. Okay. Yes. Doesn't matter what the base is, as long as it's a number. This guy is only defined for f of x greater than 0. So that means that x squared minus 2x minus 3 has to be strictly positive. Yeah. So x is less than -1 or x is greater than 3. And I hope that my colleagues last time has already covered quadratics in more details. So this should be a lot more manageable. Four, range. Look at the domain. Yes, if we're saying x is an element of all real numbers, then yes, the range would be 0 to infinity. But what if we restrict the domain to -1 to 2? Nope. Yes. A very important skill to have when dealing with exponential functions is knowing whether it is increasing or decreasing. We know the base here is 4. And we have 4 to the 2x minus, the function is y is equal to 4 to the 2x minus 1. As x increases, y increases. then we know that the exponential function is monotonic. So it's just going to be increasing for OX. We are given two parts, -1 and 2. So that means that our lower bound, the range, is going to be y of 1, y of -1, all the way to y of 2. Y of -1, that's going to be 4 to the -3. Y to the 2, y of 2, that's 4 to the 3. In other words, from 1 over 64 to 64. Part B. Wait, are you guys not familiar with this notation? Depends on where you are. The round brackets means not included or not inclusive. If you happen to go to school in the French system, they would use this guy, which is ugly as hell. But the two are equivalent. By the way, you are expected to understand the notation. But of course, when you're giving your final answer, when you're giving your final answer, just a side note, you can write like this. That's perfectly correct. You can also write this. Both notations are accepted. But you must be able to interpret. Okay. About the notation. Okay, I don't want to bore people though. Let's say from -1 to 4. What is the difference between? Okay, -1 to 4 and -1 to 4. If we are to represent on a number line, -1 is over here, 4 is over there. Round brackets show that this value is not included. Same for 4. We are only interested in the interval between -1 and 4. So the parts that we are actually interested in is this part in between. Now, I also know that some places will shade out the part that you are not interested in. But the convention is that, on the IB exam, and this is why they do not ask you to draw a number line, because different places doing different things. Likewise here, -1 to 4. -1 is included, so it has to be a filled dot. 4 is excluded, so hollow. The interval you're interested in is right in between. Likewise for the remaining two. Oh, good. Okay. Back to this. Log 1/2 of 2x for x between 2 and 8. Is this function increasing or decreasing? That's always going to be your first question. As x increases, your function should be decreasing. So your curve will actually look something like this. Cool. That means that the minimum value is actually at 8, and the maximum is at 2. Y of 8, that is a log base 1/2 of 16. Y of 2, that's log base 1/2 of, hold up, I think I messed it up. Log base 1/2 of 4. No, this is actually wrong. 2 and 8. Okay, when does it cross the x-axis again? 1/2. Okay. Actually, looks something like this. Actually, at 2, you get this number. At 8, you get an even more negative number. So your range is from -4 to -2.